So students, I am going to take up theorem number 6.6 of the chapter triangle. The ratio of areas of two similar triangles is equal to the square of the ratio of corresponding sides. So what is given? Given that triangle ABC is similar to triangle PQR. These two triangles are similar. It is given. So what I will do, I will draw a perpendicular from A to BC, that is AM, and from P to QR, that is PN. So construction. Some constructions we are doing. Construction. Draw perpendicular from A and P on sides BC and QR respectively. In this triangle, from A on BC, that is AM, and from P on QR, that is PN. Now we will go for the proof. It is given ABC and PQ are similar. Therefore, AB upon PQ is equal to BC upon QR is equal to AC upon PR. Since triangle ABC is similar to triangle PQR, it is already given, and we have already studied that when two triangles are similar, then ratio of corresponding sides are equal. So the ratio of corresponding sides I have taken over here. Now we will find the areas of this triangle. Since we have dropped perpendicular from A on BC, that is AM, and perpendicular on P on QR, that is PN, therefore area of triangle ABC is equal to half into base is BC into AM. This is the area of triangle ABC, and area of triangle PQR is equal to half into base is QR into PN. According to this ratio of areas of these two triangles, so we will take the ratio. Therefore, area of ABC upon the area of PQR. Of course, these are triangles. PQR, that is equal to half into BC into AM upon half into QR into PN. Half and half will go. We will get BC into AM upon QR into PN. Finally, we got the ratio of these two similar triangles is equal to BC into AM upon QR into PN. We will further proceed. In triangle ABM and triangle PQN, if you are taking these two triangles, angle ABM is equal to angle PQN. Why? Because these two triangles are similar, the ratio of corresponding sides will be equal and corresponding angles will also be equal. So corresponding angle B is equal to Q. You can write, since triangle ABC is similar to triangle PQR, and angle AMB is equal to angle PNQ, each 90 degree. Means in these two triangles, two corresponding angles are equal. Therefore, these two triangles will be similar. Therefore, triangle ABM is similar to triangle AQN by a criterion of similarity. By a criterion of similarity, these two triangles are similar. When these two triangles are similar means the ratio of corresponding sides of these two triangles will also be equal. So corresponding side is AB corresponds to PQ and AM corresponds to PN. Therefore, AB upon PQ, that is equal to AM upon PN. It is very good relation and very important relation is this, and we will further proceed and we'll use the areas and with this relation and with this relation. So you will take this one, this as 1 and this as 2, and this is also be used over here. That is from 1 and 2. From this and this, what we will get? Area of triangle ABC upon area of triangle PQR is equal to BC upon QR, BC upon QR into AM upon PM, AM upon PN. This we have got. Now, further we will look at let this equation be 3. So, from 3, area of triangle ABC upon area of triangle PQR is equal to BC upon QR. BC upon QR we can write AB upon PQ. So you write AB upon PQ. It's important. BC, because we want all the ratios to be same. So we will see all these relations. This relation and this relation. We will combine all these three and we will reach at the conclusion of with a particular one type of ratio. So one type of ratio means ratio of the corresponding sides. So BC upon QR is equal to AB upon PQ and AM upon PN is equal to AB upon PQ. Means both these ratios are equal to the same ratio, that is AB upon PQ. So instead of BC upon QR we will write AB upon EQ and AM upon PN is equal to AB upon PQ. AB upon PQ. That is equal to AB upon PQ whole square. Now, AB upon PQ is equal to BC upon QR is equal to AC upon PR. So, we can write ratio of these two triangles. Therefore, area of triangle ABC and area of triangle PQR. Ratio of these two is equal to AB upon PQ whole square and AB upon PQ is equal to BC upon QR whole square is equal to AC upon PR whole square. This was required to be proved. See the statement. So now we can say this is proved. So a very important relation is this, and this theorem will be applied for the questions. Now I will take the question of 6.4. I am taking the second question. First question is easy, so that you can do by your own. Second question, just I will take up and I will solve this. Diagonals of trapezium ABCD with AB parallel to CD intersect at the point O. If AB is equal to CD, find the ratio of areas of triangle AOB and COD. So ABCD is a trapezium. What is given? That diagonals intersect at the point O and AB is parallel to CD. Means these two lines are parallel. These two sides of trapezium are parallel to each other. Now, since these two are parallel, the first solution we carry ABCD, the quadrilateral ABCD is a trapezium and AB is parallel to CD. AB is parallel to CD, and this diagonal BD is acting as transversal, and since it is the transversal, these alternate angles will be equal. Therefore, angle BDO, or we can write ODC, angle ODC is equal to angle OBA. Similarly, AB and DC, these sides are parallel, and AC is a transversal, so these alternate angles will be equal. So we can write, and angle OAC is equal to angle OCD, right? So these two angles of these triangles, which one? AOB and DOC. Now in triangle OAB and triangle OCD, OAB and OCD, these two triangles we will consider. So these two corresponding angles, these two angles corresponding angles, these two are equal. It is suppose it is 1. Then from 1 corresponding angles are equal, therefore triangle OAB similar to triangle OCD, means OAB and OCD, these two triangles are similar, right? Then we have to find the AOB and COD, means in the same way. So we have to find the ratio of areas of these two triangles. So what are the corresponding sides? These two triangles are similar, so corresponding sides are AB corresponds to DC, right? Therefore, area of triangle AOB, AOB or OAB? AOB upon area of triangle COD or OCD, either way, is equal to B. AOB, this side corresponds to this side, so we will write AB upon DC whole square by theorem, previous theorem, what we have already done. So ratio of the corresponding sides means AB upon DC whole square, and it is given AB is equal to 2CD. Therefore we can write 2CD upon CD whole square. So this will go, we will get that is equal to 4. Means therefore area of triangle AOB and upon the area of triangle COD is equal to 4. This is the answer. So theorem should be remembered and its application should be done wherever it is needed. To prove this relation, ratio of the areas of these two triangles is equal to AO upon DO. What we will do first, to find the area of these two triangles, what is required? Bases should be known and the corresponding height should be known. So what I will do, so base is common, so on this base I will draw the perpendicular from the vertex. So from this vertex, this is perpendicular from here and perpendicular, this is 90 degree, let it be M and this is N. So now we will find the areas of these two triangles. Now area of triangle ABC is equal to half into base is BC and height is AM. That is the area of triangle ABC, and area of triangle DBC is equal to, that is DBC is equal to, base is BC, so half into base into height is DN. So you find the ratio. Therefore, area triangle ABC upon area of triangle DBC, that is equal to half into base into height upon half into BC into DN. Here half will go and BC will go. We will get AM upon DN. Means ratio of these two triangles is equal to AM upon DN. Now, if we could prove AM upon DN is equal to AO upon DO, then proof will be there. So we will consider the triangle AMO and DNO. In triangle ANO and triangle DNO, we will consider these two triangles. Means ANO, no, it is AMO. AMO and DNO, these two triangles will be considered. Here this is 90 degree, this is also 90 degree, right? And this angle is equal to this angle, means vertically opposite angle. So two angles or two triangles are equal, means these two triangles are similar. So angle AMO is equal to angle DNO, each 90 degree, and angle AOM is equal to angle DON, that is called vertically opposite angle. So in these two triangles, two corresponding angles are equal. Therefore, triangle AMO is similar to triangle DNO. We have proved these two triangles are similar. Then the ratio of the corresponding sides will also be equal. Means AM upon DN. Therefore, AM upon DN, that is equal to AO upon DO, this relation. Let this relation be 2 and this is as 1. So we can write from relations 1 and 2. Area of triangle ABC upon area of triangle DBC, that is equal to AO upon DO. This is proved. Question is very good. Only thing, concept should be used, how to find the area and similarity of two triangles, and finally what we are supposed to do, what is given and what is to be proved, and whatever is to be proved, all the permutations and combination, all the possibilities we have to look at. There's all the concepts, all the theories which we have already studied. So how to apply those theories, that is to be looked at, and that should be applied and to get the relation. Now I will take the next problem, that is question number 4. If the areas of two similar triangles are equal, prove that they are congruent. So given that triangle ABC and PQR are similar, triangle ABC is similar to triangle PQR. Therefore, AB upon PQ is equal to BC upon QR is equal to AC upon PR. Because these two triangles are similar, then corresponding angles should also be equal. This angle, or this angle 1, this angle 2, this is angle 3. So this is 1, this is 2, and this is 3. Corresponding angles will also be equal just because these two triangles are similar. And one more thing is given, that areas of two triangles are equal, and we know from the theorem then if we are finding the areas of these two triangles, we know that area of triangle ABC upon area of triangle PQR is equal to AB upon PQ whole square is equal to BC upon QR whole square is equal to AC upon PR whole square. Right? And areas are same. As area of triangle ABC is equal to area of triangle PQR, area of triangle ABC upon area of triangle PQR is equal to 1. Therefore, these ratios will also be equal to 1. Therefore, AB upon PQ whole square, AB upon PQ whole square is equal to 1. This implies AB is equal to PQ. Similarly, BC is equal to QR and AC is equal to PR. Means what do we observe? AB is equal to PQ, BC is equal to QR and AC is equal to PR. Therefore, triangle ABC is congruent with triangle PQR by SSS test. This is the proof. These two triangles will be congruent when the length of the corresponding sides are equal, and that is proved over here. That is why these two triangles are congruent.